Keisha Barr, and I'm here at the Texas State Aquarium in the Coral Nursery. I hope you all tuned in for the first part of the conservation series, and I'm here to talk about part 2, where we have this really unique project between Texas A&M and Corpus Christi and the Texas State Aquarium looking at coral health. So the main goal of this project was to be able to understand how healthy are the corals here at the Texas State Aquarium, and we wanted to give them a tool to use to evaluate how healthy they are. What is their wellness? Are they doing well? And what can we do to improve the health of the animals here? The goal of this was to create a really easy, effective, and non-evasive way to assess the coral health. And the way that we did that was by looking at the coral color. So you can see here I have a coral card that is only for the corals in this aquarium, and this is the first tool that was used to develop for the corals at the Texas State Aquarium. So it has not been developed anywhere else that we know of, so it's a really unique thing that we've been working on for the past year and a half.
Hi, I'm Alex. I'm a senior aquarist here at the Texas State Aquarium, and I am the coral aquarist here, so I work with all of the coral that we have. So this is our coral card, or our coral color card, and this is something that we use to help assess the health of our animals. Each one of these cards is for an individual species that we have here in our coral nursery tray, and what I can do is I can compare the color of the coral that I see with the color on the card. So these colors kind of correlate with what would be considered as a healthy coral, or an actively photosynthesizing coral.
So the reason why we developed this color card is because we wanted to give everyone this tool to be able to better assess the wellness of corals. This all started back during my PhD, where I was learning and trying to understand how corals were responding to different environmental changes. And I was working with my major professor, Dr. Paul Jokiel, and he looked at me in the middle of the night one night and was like, "Keisha, how do you tell if a coral is healthy?" And I was like, "Oh, great question. I'm going to do all of these different measurements, and I'm going to work up that data, and then I'll tell you if the coral is healthy or not." He looks at me and he's like, "No. What you do is you look at it." And there's a lot of truth to that. If you're able to look at a coral and it looks healthy, you should be able to say that coral is healthy. But not everyone had that same idea or that same understanding that Dr. Jokiel had of what a coral should look like and what that color should look like based on what species it is. So the goal of our project over the past 5 years now was to develop a card similar to this one here that would be able to put that knowledge in the hands of the public, where they could go out, they could look at colors of coral and then determine how healthy that was, and then report it back to a centralized area, and then we can get an idea of how healthy corals were. And this became very, very important during the global bleaching events that have been happening. Our waters are warming, and with that warming, we see a breakdown in the relationship between the coral animal and its symbiont. The really cool thing about corals is they're beautiful, but that color, a lot of that color comes from their algal symbiont. Some of it is from the coral itself, but it's all from that zooxanthellae, that algal symbiont. So if the relationship between the coral and the symbiont isn't doing really well, that will break down and the coral will lose its color. And what you'll see instead will be a white color, which is the coral skeleton. So the tissue itself is translucent, you'll see the skeleton, and that's why we call it coral bleaching. Can we develop a card that has from dark colors to light colors in order to understand how healthy those corals are? Turns out, people have done it before in Australia. It's the color health chart, very effective, but only for corals in the Indo-Pacific area. Yeah, which is great. That's really great, but can we take those ideas and model it after corals in Hawaii? Can we take that idea and model it for corals in the aquarium? So what we decided to do is do experiments, select the most dominant corals in Hawaii, expose them to warming, and get an idea of what that color variation looks like. So they'll start out here at number 9, dark in color, beautiful. As they're exposed to heat, the longer that they're exposed, they become whiter and whiter. And then eventually they'll become stark white. So what we did is we captured health measurements at each of these different intervals and compiled all of that together with the colors to get an idea of, okay, this color, the coral is this color. This is how many zooxanthellae it has, or algal symbionts. This is how well it's performing, how well they're doing. This is what it means together. So these are not just colors on a wheel. These are not colors on just colors on a swatch. This is also tied with a lot of biological data that tells us how healthy that coral is. So going back to what Dr. Jochil said, look at the coral, you know how healthy it is. If you look at this these would be healthy corals. These would not be healthy corals. Now everyone has that tool in their hands. In Hawaii, so this card was developed for Hawaiian corals. This card is developed for corals here in the aquarium. Now we have it, and we're hoping to do it everywhere else so people have an idea of what their corals look like in that area. And then on the back, I just want to mention that we wanted to make sure that the community could use this in a really effective way. So we have different ways that you can survey corals. You can have a transect, or you can just go out and randomly select corals. And then we want to have an idea of what the morphology of the coral is. What is the shape? Because based on the shape and the color that they distinguish on the back, we know what species of corals it is. So then we have an idea what they look like. And then the last thing is you then match the color of the coral to the color on the wheel or the color on the swatch. And then you report it online, and we have an online database where we can spatially see what the colors of the corals look like across the Hawaiian Islands. So if we have another bleaching event, we can see what they were before the bleaching event, what they are after the bleaching event. And what we're really hoping to see from all of this together is what are some areas that are more impacted, and what are some areas that are more resilient. And are there things that we can do in those areas to help alleviate some of the stress that are occurring on those reefs? One thing that they have been doing in Hawaii, we've given out about 5,000 of these. They go out, they look at their local reef, and they start taking measurements, and they report that online. We want to have some way to standardize across all of the different entities that are looking at coral health. How do we do that? We develop some standardization with a card like this. And that was the biggest thing in science, is everyone's doing something different, and we can't compare what different areas look like. Same thing with zooms at aquariums. Everyone has their own way to detect wellness. So how can you compare how well your animals are doing to other animals in other facilities? This is a way that we can make it a little bit more standardized, so we can share that information and share tips and tricks on how to do better at taking care of our animals.
Some of the things that I do on a day-to-day basis with them is we check the water chemistry. So every day we check salinity, pH, temperature, and then occasionally I'll go through and I'll check all the calcium, alkalinity, and magnesium levels to make sure they have the minerals in the water that they need to help calcify their skeletons. One of the other things that I do on a semi-regular basis is I go through and I try and scrub all the algae off of the actual coral frag, or the rock that the coral is mounted on. The algae tends to, their presence can stress the coral out or kind of irritate them, so we want to make sure that the rocks that they're on are as clean as possible. So the lights that we use for our coral tanks here at the aquarium are a special spectrum of light. So they focus heavier on the blue side of the visible light spectrum. And part of the reason for this is because that spectrum of light is what coral primarily use for photosynthesis. So one way that we measure the intensity of the light is we have something called the PAR meter. And PAR stands for photosynthetically active radiation. And it's just a little meter that we stick next to the coral, and it kind of gives us a gauge of the intensity that they're receiving. So we want to make sure that they're not getting too much light, because that can actually be stressful to the coral as well. But we want to make sure that they're getting enough light so that they can properly photosynthesize.
For example, the cropora in here are almost growing out of the tank. They're doing really well in these conditions. And if people in other zoos and aquariums are having some issues, it'd be good to know, hey, what are you guys doing? What do your conditions look like? Do you mind sharing some tips and tricks? Because it would be really helpful for us to be able to grow these corals, because this species is extremely endangered right now. It used to be very populated across the Caribbean. Now it's extremely threatened because of the changes that have happened. And we're concerned that we might lose this species altogether. But we do have it here in the aquarium. It's doing really well. in absence and in separation of what humans are doing in the coastal waters there. These corals, these Acrophora species, were the major reef-building coral in the Caribbean, and now we've lost a lot of them. And it's just very scary of how fast we lost them. But you can see they're doing really well here. They grow really well. It's because these are optimal conditions for corals. Corals are they're amazing creatures, but they're very sensitive and particular about their environment. So if anything changes, the temperature, the nutrients, the light levels, the chemistry of the water, it really impacts them, because you're not just dealing with the animal, you're dealing with the algae inside of them, you're dealing with the bacteria, the fungi, the viruses associated with them. So they're very complicated animals, and if we can find a way to culture them and keep them and let them grow, then we might have hope for the future. And I think that's extremely important for people to understand, is they're very sensitive, and we need to do what we can to help make sure that they make it.
One of the things that we do here at the aquarium, we do a lot of conservation work, and you might see a lot of conservation work, especially with sea turtles this time of year, and marine mammals, but coral is actually one of the other things that we do a lot of conservation work with as well. Coral reefs are under a lot of stress because of things like climate change, and that's one of the reasons why they're really important to us here at the aquarium.